Hi folks, Mr. Long here. Today we're going to talk about derivatives of sine, cos, and tan. It's a fairly intuitive process, with the exception of tan. We're going to need some algebra. And we can prove the derivative of sine and cos with some significant algebra, but we'll leave that for a later point in time. Today is going to be about knowing why the derivative of sine is what it is, and the derivative of cos. Okay, so let's take a look at this. We've got a graph here of sine. Let's figure out the derivative. Oh, remember, from a language perspective, or rather terminology, I guess, d by dx means you haven't differentiated it yet, okay? So this means we haven't differentiated sine, but we want to. So we want to come up with a formula for the derivative of sine. So here's our nice sine graph right here, and that sine graph goes between 1 and -1. So let's do this by just drawing tangents on the curve. So there's a tangent, there's a tangent, there's a tangent, there's a tangent, and there's a tangent. So now let's draw what the slope of those, because remember the derivative is the slope of the tangent. So what's the slope of that curve? Sorry, what's the slope at x equals 0? Well, it's positive. We'll put it up here. What's the slope at pi by 2? Well, the tangent is horizontal. You can see that the tangent is horizontal there, so it's 0. What's the slope of the tangent at pi? Well, the slope is very, very negative there. And then at 3 pi by 2, it's flat. So what's that slope? That slope is 0. And finally, at 2 pi, we have a tangent that is positive, so the slope is positive. It's here. Now, let's connect the dots. What curve does that look like? You guessed it, it's cos. So the derivative of sine is, in fact, cosine. Okay, so that's our first rule. Let's do the same thing now for cos. So let's draw tangents at 0, tangent at pi by 2, tangent at pi, tangent at 3 pi by 2, and a tangent at 2 pi. And now, what are the slope values? Because we know the derivative is the slope of the tangent. So at x equals 0, the slope is 0. At pi by 2, the slope is negative. At pi, the tangent is horizontal, so the slope is 0. At 3 pi by 2, the slope is positive. And finally, we have a horizontal tangent at 2 pi, which brings us back to 0. So connect the dots. And what curve is that? You probably guessed that one correctly as well. It's the negative sine graph. Okay, so the derivative of sine is cos, and the derivative of cos is negative sine. What about the derivative of tan? Okay, for tan, so some things that we need to think about. Tan is worth y over x on the unit circle, which is just sine over cos. Okay, so I need to get the derivative of sine over cos. If I can get the derivative of sine over cos, I've got the derivative of tan. Sine over cos is a quotient. There's division there, so I need to use the quotient rule. If a function is top divided by bottom, then the derivative is top prime multiplied by the bottom minus bottom prime multiplied by top all over the bottom squared. The top is sine, the bottom is cos. So now we can use our understanding or our knowledge that the derivative of sine is just cos, and the derivative of cos is negative sine. Okay, let's go through and do this then. So I'm going to put things in. Top, prime, bottom. So what I'm doing is using the quotient rule. So the top prime here is cos, so I start with that. So it's going to be cos x. Then I multiply that by the bottom, which is cos x again. Minus, and then it's bottom prime, right? Bottom prime there. The bottom prime is negative sine x. And then I multiply that by the top, which is sine x. Okay, and that's all divided by the bottom squared. Well, the bottom is just cos. Divided by cos. All divided by cos, but it's going to be squared, right? Because the bottom is squared. Okay, so what does that work out to? Well, I think you can see that is cos squared and those two negatives there make a positive, and then that's going to be, so it's going to be plus sine squared. What is cos squared plus sine squared, or sine squared plus cos squared? It's nothing more than 1. So y prime equals 1 over cos squared x. But 1 over cos is sec. So it's sec squared x. Okay, so my derivative of tan x is sec squared x. Okay, and are you responsible for that derivation of that? Yes, you are. It is possible that I will ask you to prove that the derivative of tan is sec squared using the quotient rule. All right, now that we've done that, let's go and do some examples. Okay, so all of our examples that we're going to do today are going to involve the chain rule. I don't know if you remember the chain rule or not, but the chain rule says if I've got a function that's a composition, so g of x is inside f, then what I do is I do the derivative of the inside, g prime of x, and then I multiply that by the outside derivative, f prime of g of x. And another way to write it is inside prime times outside prime. Okay, so let's do this. Number 1, y equals sine of x squared plus 1. So the inside derivative is 2x, and the outside derivative is cos of x squared plus 1. Okay, and you're done. 2x cos x squared plus 1. Okay, inside prime, outside prime. By the way, that's the inside prime, and that whole thing is the outside prime. Next, 3 cos 4x plus 1. Okay, so the inside prime is 4, the outside prime is, and I'm just going to treat it this way, right? The 3 is just a coefficient, so the outside prime is going to be negative sign brackets. Okay, so it's going to be y prime will equal 3 groups of, well, first I'll do the inside prime, which is 4, multiplied by negative sign bracket, and in the bracket is 4x plus 1. Okay, so all taken together, that is y prime equals 3 times 4 times by negative 12 sign bracket 4x plus 1. Okay, and remember, pause this at any time, rewind it, watch it again. The third one, y equals x squared tan x. So that's a little bit hard to see, sorry. X squared multiplied by tan x. This is the product rule. So the product rule is if y equals f times g, y prime is f prime g plus g prime f. Okay, so the derivative of the first times the second, derivative of the second times the first. And this is pretty easy. The derivative of x squared is just going to be 2x. The derivative of tan we've learned is sec squared x. So y prime equals, so the derivative of the first is 2x times by the second, tan x, plus sign. All right, that plus sign is the same as that plus sign, and now I have to do the derivative of the second times by the first. So the derivative of the second, the derivative of tan x is sec squared x multiplied by x squared. Okay, and I could leave it there, or I can factor out. There's an x there to be factored out, so I can factor out the x, and I'm going to be left with 2 tan x plus x sec squared x, and I'm done. Okay, so that's it for today, for this screencast. And what you can do now is you can go over all of your examples and go from there. Okay, so go over these examples again, and then just work on the questions that have been assigned. Okay, have a good day.